Good morning students, welcome to the lecture 3 of Probability and Statistics GATE DA series. Today we will learn about mutually exhaustive events and mutually exclusive events. If union of two events cover all the elements present in the sample space, then those two events are called mutually exhaustive events. If union of two events cover the entire sample space, that means A union B, if this thing covers the entire sample space, then A union B is called mutually exhaustive events. We already learned that the formula of A union B is equal to mod of A plus mod of B minus mod of A intersection B. But this is for those two events when they have something common between them. But when they have nothing in common, suppose head and tail. Head, what is the union of head and tail? We already know that head and tail are not dependent to each other. So here the formula will be only mod of head plus mod of tail. Okay, this portion will not be needed here. So this formula is valid for those events who are dependent to each other. But this formula is valid for those events who are independent of each other. Independent of each other. So tossing a coin, throwing a die or drawing a card, those are all example of mutually exclusive events. Because union of all their events represent the sample space. Head union tail represents the entire sample space. Here 1 union 2 union 3 4 5 union 6 represents the entire sample space. And also here 1 union 2 union union 52 represents the entire sample space. So if union of all events represents the entire sample space, then they are called mutually exhaustive events. So what is mutually exclusive events? Mutually exclusive events are those two events if there is nothing common between them. That means suppose A is an event, B is also an event, but there is nothing common between them. We already knew that example where A is equal to Shah Rukh Khan, but here B is not Salman Khan, B is equal to Sanjay Dutt. Here there is nothing common between A and B. Shah Rukh Khan, Sanjay Dutt, nothing is common between them. These kinds of events are known as mutually exclusive events. They have nothing common between them. So formula of these mutually exclusive events are A intersection B is equal to 0. So intersection of these two events have nothing in common. This is also represented by A intersection B is equal to 5. That's it. So example of mutually exclusive events are also tossing a coin, throwing a die and drawing a card. But we already learned that these three are also example of mutually exhaustive events. So how these events can be both mutually exhaustive and mutually exclusive? This is a catch. Here, if we toss a coin, head union tail is equal to mod of head plus mod of tail. But here, head intersection tail is equal to 0. They have nothing in common. So this example satisfies both the mutually exclusive ones and the mutually exhaustive ones. Because union of them represent the entire sample space, they have nothing in common. So they are both mutually exclusive and mutually exhaustive. So these three examples, tossing a coin, throwing a die and drawing a card, both mutually exhaustive and mutually exclusive events. So in simple words, if A union B represents the entire sample space, then it is called mutually exhaustive events. And if A intersection B has nothing in common, then it is called mutually exclusive events.